So I have information. That's the whole idea of Western science based on negative empiricism. We can rule out some things, and here we can rule out that this is degenerate. In other words, deterministic. Sorry, I don't know what words you use for degenerate. That is politically correct, but that's the one still used by mathematicians, all right? So degenerate distribution is one that has no randomness in it, okay? And no variation, okay? So you have an additional variation. Okay, so this distribution can hide as this, but this one cannot hide as that, okay? This gives us a very easy way to deal with randomness. Because if I see a 20 sigma event, I can rule out that it's entailed. If I see no large deviation, I cannot rule out that it's not fat-tailed, unless I understand the process very well. This is how you can rank distribution. So here, I have the tableau that I showed you before, and we can start seeing deviation and ruling out from the bottom. You see? And the true distribution rule out progressively all the way to go up to 1. And those are based on how they can deliver tail events. You see, so this is a technique. I don't have a lot of time. This is worth flying in and spending time bickering with philosophers and logicians about it. But so this is ranking distribution becomes very simple because someone tells you it's a 10 sigma event. It's much more likely that you have the wrong distribution than having a 10 sigma event, okay? And likewise, fat-tailed distribution, as we saw, don't deliver a lot of deviations often. Once in a while, you get a big deviation. So we can already rule out what is not mediocre stand. Like we can rule out in finance and economics that we are not. We can rule out mediocre stand. We are not in mediocre stand. I can say this distribution is fat-tailed by elimination. I cannot certify that it's thin-tailed. That's, again, to repeat it, the Black Swan problem. Let's continue now. Pareto class. Now I have two pictures of Pareto. One when he was young, before he discovered the Pareto distribution, which is a power law, and one after. And you see what happened to him after discovering the distribution. In the meanwhile, he had a Russian wife whom he met in Venice who left him, okay, with his 22 cats, all right? So you can understand, and something common here to have a Russian wife, but except that in the case of Pareto, from what I hear, compared to your local resident who had a Russian canes, he apparently slept with her. So that's what. So she still left him. That's probably why she left him. Whereas with canes, all right. So that's what. So now we know about Pareto. Okay. So what is important about Pareto? This is the math, but let me give you the intuition. Okay. Let's say that we have a Pareto distribution. Probability of richer than 1 million, 1 in pounds, or whatever you want, lira, the Italian, whatever you want, okay? 1 in 62 and a half. Do you see a logic here? Richer than 32 million, 1 in how many? Sorry? You multiply. So the ratio of people with over 50 million over 25 million is similar to the ratio of 500 million over 250 million. You see? So this distribution has no characteristic scale. It makes it very easy to understand. The ratio of people who are 500 pounds over 250 pounds is not the same as 1,000 pounds over 500 pounds. You see, in the thin tail. For fat tail, that class of fat tail, we have 3 classes of fat tail. That's the one to the extreme right, sort of the Le Pen of fat tails. So that has this characteristic that makes it very easy to understand. Okay, for large deviation, it may not start at 1 million for large deviation. I'm simplifying. Another one, how many are richer than 32 million here? 2,000, no? We understand you can do it on a napkin. Now, what do these two have that is problematic for statistician? Sorry? This distribution has no mean, and this distribution has no standard deviation. We still understand it, no? Well, get used to it. You're going to have to ditch standard deviation, and you still understand what's going on. And for extreme events, you had to ditch the notion of mean, because it becomes meaningless. You're only interested in the extreme event. Okay? So forget the mean, or you can't compress things in a fortune cookie style statistical textbook. You can't, right? So ditch the statistical textbook. Forget statistics and relearn how to deal with these things, okay? So, and now I have bad news for people in economics, except for those at Cambridge, because of course they're one class apart, but I'm saying that people in economics in the US have a problem with the following. And this is what really made me bitter. People wonder why I have this allergy to the economics establishment, and it came from this. When and let me give you the point. We said that in the Gaussian world, or in the thin-tailed world, a measure of fat-tailedness is what? The fourth moment, no? So I took, that was in 2009. I took 55 years of data and looked at how much of the kurtosis came from the largest observation. For the S&P 500, it was about 80%. You see? What does it tell you? It tells you we don't know anything about kurtosis. If you don't know anything about the fourth moment, you know nothing about the stability of second moment. It means you're not in a class of distribution that allow you to work with variance, even if it exists. That's finance. So here I have financial data, silver future. In 46 years, the 94% of the kurtosis comes from one observation, S&P 500. I mean, you can replicate it, take the top 3, because since 2009, we've had some tail events. So look at this. This is not consistent. If I take, this is not at all consistent with anything you can use standard statistical methods with. Okay, that's not. Because something called Garch doesn't work, because you're dealing with squares. The variance of the squares, sort of as the fourth moment, doesn't work. Okay, it means we don't know the variance. But you can work very easily with Pareto distributions, which gives you less information, but nevertheless, it's more rigorous. You cannot invent information. So this I discovered. So basically, based on this, I kept writing. I wrote on the Black Swan. I revised it on the Black Swan. I said, anytime you hear standard, you read a paper, you see if they use any moment, you take it, you tear it, there's a shredder, you put it in a shredder so it goes back to nature, and then put it in a recycle bin. The recycling, then they make paper with it, whatever it is. You get the idea, all right? But don't continue reading it if it has standard, unless it is capped.